NEET most expected 1000 question series. So in this 1000 most expected NEET series, we started 45 days program. So far, structure of atom is completed, practical organic chemistry is completed, periodic classification and chemical bonding and thermodynamics is completed. So the questions are selected in such a way that the questions are direct at the level of NEET level, and some of the questions definitely you can expect the same model of the questions on the NEET upcoming 2025 examination. How are you all? Can you all able to see me? Can you all able to hear me? Just give a confirmation so that we can start. आज हम पेश करने वाले हैं इक्विलिब्रियम नीट पार्ट 1. So most awaited topics in the total chemistry paper. Hi Mohit Soni, good afternoon. So in the total NEET examination paper, the most expected topics thermodynamics and chemical kinetics and equilibrium. These three definitely you are going to get a question, and a sure shot question. Good afternoon. So equilibrium is one of the lengthiest topic in the entire physical chemistry part. So I just want to take 3 sessions for this. Equilibrium part 1, part 2 and part 3. Part 1 I just want to focus on chemical equilibrium, and part 2 and part 3 I just want to focus on ionic equilibrium. Is that fine? And also we are planning to give some topics based on chemical kinetics after this, and we can also see electrochemistry. So far we are in the discussion of physical chemistry. After completion of this particular topic, I just want to give a break for the physical chemistry, and I want to go into the organic chemistry, GOC, again part 1, part 2 and part 3. There we can see all organic reaction based, mechanism based and the electronic effect based questions. Stay tuned for every day. My session is going to be 1:30, and you just expect minimum of 35 to 45 questions per day. In the series of 45 days, if you take average of 35 questions, you are going to reach up to 1500 questions. Among these 1500 questions, can you believe it, you are going to write 45 questions. So definitely with our experience, we are taking the questions from that, and you are practicing well, and many students are regularly attending the classes like Monica, okay, Hemant, I'm waiting for them, Mohit, and you just see student always have a kind of a doubt in the mind like, sir पढ़ाया अच्छा किया लेकिन क्वेश्चन सॉल्व करने का वक्त में थोड़ा सा दिक्कत आ रहा है, कॉन्फिडेंस कम आ रहा है. सो एक कॉन्फिडेंस रखने के लिए, एक कॉन्फिडेंस सब्जेक्ट में बढ़ाने के लिए आपका ये इक्विलिब्रियम एंड ऑल टॉपिक्स नीट मोस्ट एक्सपेक्टेड क्वेश्चंस लॉन्च किया गया है ना, राइट. सो व्हाट लेट शैल वी स्टार्ट बिफोर. हाय राम कार्तिक, दैट्स गुड. सो दैट्स द सेम थिंग. So students are preparing well, but when you attend the question now, you are having a lack of confidence. To increase this confidence, these topics are given. So before going for the topic, hi, I just want to give a word for the day. Every day you should have one word to crack your NEET examination. For that, every day you attend the classes with me and take a pen and paper, solve the questions along with me and do the questions and increase your confidence. And also like the sessions and share with your friends and subscribe to Infinity Learn NEET YouTube channel, so that you will be having continuous updates, and bell button dabaओ आपको मिलेगा, and the Google Play Store, and you will be having Infinity Learn app. You download it and you will be having live classes, mock test, create your own test and 24/7 doubt resolutions, and everything is free for you. And this YouTube channel, well experienced faculties are coming and explaining the concept as well as questions that boost a lot. So while at chemical equilibrium, in that chemical equilibrium, what I plan, I just want to just short revision of the topic and we'll go into the MCQ. Is that fine, Mohit and Ram Kartik? Is that fine, or you want me to directly go into the questions? Option is yours. Option आपका है. Okay, so let's talk about the equilibrium here. So when a chemical reaction, yeah Mohit, when a chemical reaction is there, so a reversible chemical reaction, you can say A plus B gives rise to C plus D. This is a forward reaction, this is a backward reaction. At equilibrium, rate of forward reaction is equal to rate of backward reaction. Rate of forward reaction is equal to rate of backward reaction. That is the state of equilibrium. And the concentrations or active masses in mole per liter, reactants and the products becomes constant. And you can say delta G is going to be 0, Gibbs free energy change is going to be 0 at the state of equilibrium. At the state of equilibrium, you can say rate and with respect to time, rate of forward reaction decreases, rate of backward reaction increases, and there will be a situation rate of forward reaction is equal to rate of backward reaction. That is what you say. So it is a forward reaction, this is what you say backward reaction, and this situation is called as equilibrium state. At equilibrium, rate of forward reaction should equal to rate of backward reaction. And also concentrations, you can say concentrations, okay. So concentration with respect to time, concentration of the reactant, concentration of the product, and the concentrations remains constant. It could be high Monley, okay, it could be K is greater than 1, K is equal to 1, K is less than 1. It all depends upon the position of the graphs they occupy, right beta? And let's see some more details. At equilibrium, reaction coefficient equal to equilibrium constant Kc. Qp is equal to Kp as well. And also you can say the equilibrium constant K is the rate constant of forward reaction, ratio of the rate constant of the forward reaction and rate constant of the backward reaction. That ratio is called as equilibrium constant. This is called as law of chemical equilibrium. And moving ahead, equilibrium constant in terms of concentration Kc is equal to product concentration upon reactant concentration, whose molar concentrations are raised to their stoichiometric numbers by using a law of mass action. And also equilibrium constant in terms of partial pressures Kp is given partial pressures of the products upon partial pressure of the reactants, and their active masses are raised to their power terms. And what is the relation between the Kc and Kp? So bachcho, you can talk to me and it's a live interactive session, you can discuss things, okay. So after 5 minutes the concept is going to be completed. I am going to give some tricks as well, you please make a note of it. So it is strongly recommended whenever some concept we are doing, for practice you are doing, just quickly revise the concept, then you start practicing, then it is going to be super awesome, है ना? Next, relation between Kc and Kp. Moving ahead, equilibrium constant in terms of mole fraction is also given. So take a pen and paper everybody and write all the expressions so that it is going to be a round of preparation. Kx, x is a mole fraction, that is a product of the mole fraction of the products and the product of the mole fraction of the reactant, whose terms are raised to their power of stoichiometric numbers. And here relation between Kp and Kc. So what is Kp and Kc relation? Kp is equal to Kc RT to the power delta n. And relation between Kp and Kx, Kp is equal to Kx pressure to the power delta n. What is delta n? Sanjay Kumar, follow. So delta A n G is equal to, we already seen this in thermodynamics as well. sum of the number of the gaseous products minus sum of the number of the gaseous reactant, right? If delta n is equal to 0, Kp is equal to Kc. If delta n is greater than 0, Kp is greater than Kc. If delta n is less than 0, Kp is less than Kc. Okay beta, बच्चों, Sanjay Kumar, this is the NEET examination preparation platform beta on the YouTube channel. Okay, so 10th क्लास का और एक लाइव चैनल है, आप वहाँ पर बैठ सकते हैं. ठीक है, चलो. And you can see 1/2 equation log K2 upon K1 is equal to delta H by 2.303 R 1 by T1 minus 1 by T2. So what is this T1? At temperature T1, rate constant is K1, and temperature T2, rate constant is going to be K2. Delta H is equal to enthalpy of the reaction. आपको अभी चाहिए. ओके, इसके लिए अलग चैनल है, यहाँ पर ज्वाइन करो. सो शायद ये लाइव क्लासेस भी तैयार है 10th क्लास के लिए. ठीक है बेटा, चलो नेक्स्ट. You can say relation between equilibrium constant and standard Gibbs free energy change, and it is very important, and this is related to Gibbs free energy thermodynamics. We already discussed about this. So standard Gibbs free energy change is equal to minus 2.303 RT log K. How did you get this? Yeah, yes, delta G is equal to delta G naught plus 2.303 RT log equilibrium constant QC, reaction quotient QC. So at equilibrium क्या situation चलेगा? Delta G is equal to 0, QC is equal to KC. ताकि इसका 0 is equal to delta G naught plus 2.303 RT logarithm to the base 10 of Kc लिखना है. So I just want to take the delta G naught this side, so that delta G naught is equal to minus 2.303 RT log Kc. So anything can be asked, right beta? During examination anything can be asked. It is not actually derivation, using the mathematical expression. ठीक है? So next one, reaction quotient. The values of the expression for reaction quotient is given C D upon AB. मान लो A plus B gives rise C plus D, and here the situation comes like if QC is equal to KC. So I just want to say the reaction is completely at equilibrium. If QC is greater than Kc, so that reaction favors in the backward direction. If QC less than Kc, जिसका Kc ज़्यादा है, ये reaction आगे बढ़ने की कोशिश करता हूँ. So reaction favors more in the forward direction. Based on this particular logic, definitely you can get a question at any corner from the equilibrium concept. This is a very important, can be used to predict the direction of the reaction. Bachcho, hope you understand. Ram Karthik, Mohit Soni, Maunika is there in the class today. Hemant is there in the class today. Come on, who are there in the class, regular students? Okay, and degree of dissociation on alpha. Alpha is the number of moles dissociated upon number of moles taken. Okay, so fraction of molecules dissociated out of 1 mole. So percentage of dissociation, alpha is multiplied with 1. So if 100% dissociation, alpha is equal to 1. 50% dissociated, alpha is equal to 0.5. 10% dissociated, alpha is equal to 0.1, like that. And observed molecular weight and observed vapor density, based on this dissociation, N2O4 dissociate to gives rise NO2. So in that you are going to change the vapor density of the equilibrium mixture. There you can use this Khatarnak formula, you can use d minus d upon n minus 1 into d. D is the vapor density, absorbed vapor density, and n is the number of molecules that are dissociated, right? And this is very, very important. It is very, very important. You can use this for calculating, if it is used to calculating a molecular mass of the equilibrium mixture as well. Okay, MT stands for molecular mass theoretical, and absorbed molecular mass, and upon n minus 1 absorbed molecular mass, and also Le Chatelier principle. So since a decade, any entrance examination of more than half a dozen times the questions has been asked based on equilibrium and effect of equilibrium, factors effect of equilibrium, that is Le Chatelier principle. So Le Chatelier principle says a system at equilibrium may be a reaction at equilibrium. So at equilibrium, if you disturb the equilibrium like a change in concentration, pressure, volume or anything, the equilibrium is going to reattain its state. So the equilibrium is always try to reinstate it. Okay, so that is about equilibrium rule, Le Chatelier principle, and this is used for various cases, and the conditions also we made a good number of questions based on that. We'll discuss that. Effect of concentration. If the concentration of the reactant increases, what happen? QC is going to be decreased, Kc value say. So that reaction always favors in the forward direction. And if the product concentration is increased, so what happen? QC value will be increased. So that reaction favors in the backward direction. Jai, hello. And in general, if reactant concentration is increased, reaction favors in the forward direction. If product concentration is increased, reaction favors in backward direction. समझ में आ रहा है क्या बेटा बच्चों? Very good. Quick recapture. One chapter you want to study now, it takes 3 days for revision. Okay, at least 1 day for revision. But in this session, we are revising and doing questions based on this also. Now, effect of volume. If volume is increased, pressure is decreased, mind it. Volume inversely proportional to pressure as long as the temperature is constant. So that reaction shift in the direction which pressure increases. That is in the direction in which the number of moles of gases increases and vice versa. Okay, clear? And also, if the volume is increased, then for trick is given here delta n 0 for that reaction, the reaction will shift in the forward direction. Yes, you are reading NCERT, it is an extract of NCERT even better, Jay. And if delta n is less than 0, the reaction shift in the backward direction, and delta n is equal to 0, कुछ फर्क नहीं पड़ता, reaction equilibrium has no effect. Okay, so this is about the effect of volume. Let us see effect of pressure. You simply apply the opposite effect. Okay, effect of pressure. As the volume and the pressure are inversely related at constant temperature, so whatever these happen, it happens in the reverse way. Okay, are you getting or not? Clear? Hemant, why you are late? Hemant, why you are late? I am just praising for you. Okay, chalo, you continue here. 3 times I asked in the class. Hi Ram Karthik, Mohit Soni, come on Jay. And let's talk about effect of introducing inert gas addition. That's very, very important. Inert gas or any inert material, let us say. So in that case, at constant pressure and constant volume, if you add inert gas at constant pressure, you are going to get the same effect of increase in the volume. Okay, and if it is at constant volume, it has no effect at all. It has no effect at all. If inert gas is added, then to maintain the pressure constant, the volume increased, hence the equilibrium shift in direction that the larger number of moles of gases is formed. Okay, you're reading and not seeing the notification. So that's why you just click this bell button. Okay. Yes, of course, PYQs are also there. PYQs are also there. Okay, beta, Jaish. Now let's talk about, मान लो ये रिएक्शन का डेल्टा एन जी ग्रेटर देन 0 है, the reaction shift in the forward direction. If delta n is less than 0, the reaction shift in the backward direction on introduction of inert gas. If delta n is equal to 0, the reaction has no application at all, right? Any doubt? So this is true in the case of only constant pressure. What happens if constant volume? No effect at all. Inert gas addition has no effect at constant volume. This is a super awesome slide. This is a super awesome slide. So everybody take a snapshot of it. Jaldi khatam kar lo. Hemant, write down quickly. So get ready with pen and paper. Question and answer शुरू कर देंगे. Next, effect of temperature. If temperature is increased, what happens? Equilibrium constant only depend on the temperature. Any other factor can change the shift of the equilibrium, that's it. But equilibrium constant, जब तक temperature constant है, तब Kc भी constant है. Okay? Done. And if you plot ln k versus 1 by t, ln k, you just want to say log k. Okay, and 1 by t plotted, then again it's a straight line with a slope minus delta h by r, you are going to get it. So you are going to see a graph like this, ln k and 1 by t, you are going to get a straight line with a negative slope, and slope is going to be minus delta h by delta h by r. So for endothermic processes, as temperature increases, reaction always favors in the forward direction. For exothermic process, it is going to be in the backward direction. It's very important fact. It is very important fact. So for delta H is equal to 0, the reaction shift in the forward direction with increase in temperature. And for delta H is less than 0 and vice versa will happen. Got it beta? Any doubts? Clear? Any doubt? Clear? Next, thermodynamics of equilibrium, 1/2 equation, we already seen this. If you have any doubts, you just ask me, we discussed this. T1 is the temperature 1 and its rate constant is K1, equilibrium constant K1, temperature T2 में equilibrium constant K2 होगा. Delta H is equal to enthalpy of reaction, R is gas constant, and we also discussed this, delta G is equal to delta G naught plus 2.303 RT log Q. What makes the difference between these two? Students, what makes the difference between these two? Gives free energy change at standard state at 298 Kelvin, 1 atm pressure, and it is at any stage, any temperature, at any pressure. Okay, this is at standard condition. Temperature is equal to 298 Kelvin and pressure is equal to 1 atm pressure. Here it is at any temperature and pressure. या आज केमिकल इक्विलिब्रियम का है ना, सैटरडे अनाउंस किया ना हेमंत बेटा. कैटेगरी मोस्ट एक्सपेक्टेड 1000 expected questions. So today 30-35 questions pakka. And here it is a question. Here it is a question. In the reaction, PCl5 gives rise PCl3 gives rise Cl2. Degree of dissociation is 30 degrees, 30%. Okay, if initial moles of PCl5 is 1, then total moles at equilibrium. आप करना है, मैं करना है, जल्दी बताओ. Okay, come on. Who is going to do this? Answer Medhu, Jay, Hemant, Monica, I think she is not well. She'll be coming. Okay, come on. So how to solve this question? So my answer आता है आपका 1.3. कैसे? Let's say PCl5 on dissociation gives rise PCl3 and Cl2. Initially 1 mole are taken. Okay, so when time is equal to 0, so when time is equal to at equilibrium 30%, mean to say alpha is equal to 0.3. So it is going to be 1 minus 0.3 react होने तो 0.3 and 0.3 moles होगा. So that equilibrium moles, number of moles total is going to be 1 minus 0.3 plus 0.3 plus 0.3. आपका आएगा. So I want to say it is going to be 1 plus 0.3 is going to be 1.3. Understand, your answer for this question is going to be A. Clear? Any doubt you can ask us. Now next question. This is for you. You only have to do it. Come on. Okay. Now, in equilibrium reaction, H2 plus I2 gives rise to HI. H delta H enthalpy of reaction is 3000 calories, which factors favors the dissociation of HI. You want to do numerical based on this? You want to do numerical based on this? It is not at all a numerical beta. Not at all a numerical. Give me the answer, fatafat. So these are the kind of questions you can expect in the NEET examination, bachcho. So when you check the previous year questions also, the same level questions have been given. You just tell me in the chat box what is the correct answer for this. You want to say C? AC పెట్టండి వేడిగా ఉంది బాబు. Yes, it is. Formation of HI is exothermic, so that dissociation of HI is going to be endothermic. So it is going to be positive 3000 calories, so that it is endothermic. For endothermic, the reaction is favored if the temperature is high. Hemant, correct? Understand? Any doubt? Answer is C. I am going to accept your answer. And next question is going to be N2 plus 3H2 gives rise to NH3. Le Chatelier principle. Yes, exactly, we discussed that. Okay, so if the temperature of the equilibrium reaction increases, then the reaction is going to be, so formation of ammonia is going to be, delta H is going to be negative, mind it, so that it is exothermic process. As this is an exothermic process, as temperature increases, the reaction favors in the backward direction. So shift in the left side, Yes, clear? And one more question, it's a mixed match question, so for all things will come, don't worry. Next, C plus H2O gives rise H2 plus CO. By increasing the pressure, which of the following will take place? So we all know Le Chatelier principle, but when you apply left right gone, your confusion goes wrong. Okay, So for this I just want to calculate delta n. So it is going to be 1, 1 and it is 1 and it is 0. So it is a solid, that's why 0. So 1 plus 1 minus 1 plus 0 is going to be plus 1. So मान लो delta n is less than 0, pressure increases, reaction आगे बढ़ता. If delta n greater than 0, pressure increases, reaction will come back. So by increasing the pressure for the following equilibrium, so what happened? It is a positive reaction, proceed in the backward direction. It is going to be B. You see how simple the question can be solved. How simple the question can be solved. Any doubt? Yes, of course. Yes, of course. Perfect. And unit of equilibrium constant Kc for the following homogeneous reaction. Gaseous reaction. आप कौन कर सकते हैं? Okay. So Kc is going to be concentration to the power delta n. Mind it. Concentration to the power delta n. इसका delta n क्या होगा? सब gases बोल रहे हैं. So this is gas and this is gas and this is gas and this is gas. Gases बोलना, right? So that delta n is equal to sum of the number of moles of gaseous products minus sum of the number of moles of gaseous reactant. So 4 plus 6, 10, 4 plus 5, 9. So 10 minus 9 is equal to plus 1. So concentration per plus 1. Understand? The answer is going to be B. Answer is going to be B. Hemant, good. Good analytics. Students are doing so nice. And those who are not actually responding in the chat box, I expect strongly to reciprocate in the chat box and talk to me, and we can have a very good interactive session. Otherwise, this kind of sessions are going to be like only one side radio telecasting jaise jana hai. So I don't want to do that. I want to see the questions and answers, and kind of rapport should be built. Okay, on YouTube platform, it is purely service oriented, so students can expect a very good thing from us, and it is absolutely free. And you want to do the same kind of thing, and you have to go to the coaching center, pay a huge amount of money, and also same thing happens here for free of cost. Everybody please attend the classes on a regular basis and interact with us, and we can do the best in the YouTube channel. Next question is going to be, which of the following factors shifted the reaction PCl3 plus Cl2 gives us PCl5 at left side? So you have to check ये डायरेक्शन में रिएक्शन प्रोसीड करने के लिए कौन सा फैक्टर है. सो यू कैन एडिंग PCl5, इंक्रीज इन द प्रेशर, कांस्टेंट टेम्परेचर, यू कैन ऐड ए कैटलिस्ट. PCl5 जो है ना, ये प्रोडक्ट है. अगर प्रोडक्ट कॉन्सेंट्रेशन बढ़ता है एंड रिएक्शन is going to favor in the backward direction. So the answer is going to be reactant PCl5 is product PCl5 is added. ठीक है बेटा, चलो next question. So simple basic understanding level in the NEET examination, I can say basic understanding level questions, more than 60% questions will be there, mind it, and average questions will be near about 20%. Okay, 60 plus 20, and you are going to get 80% paper in your hand, and only 20% पेपर above average difficult level में होगा. मैं आपको ये difficult questions भी करने के लिए मदद देना चाहता हूँ, and there your NEET score is going to be decided. So in this NEET examination, I just want to say examination is a festival, because we are all doing definitely such a hard work. Okay, yes, increase in the pressure, reaction shift backward. No, once ये भी हो सकता है, both are correct. क्योंकि नहीं, I want to take back. That's a trap. That's a trap. ये इक्विलिब्रियम का डेल्टा एन इज गोइंग टू बी -1. It is going to be -1. So if pressure is increased, reaction favors in the forward direction. Hemant, fine? Your doubt has been clarified, so that this cannot be the option constant pressure. Really good, nice. और एक क्वेश्चन है, in which of the following process reaction is fastest to complete? मान लो Kc value is less than 10 power -3. Kc value lies in the range of 10 power -3 से 10 क्यूब तक है. If the Kc value is greater than 10 cube. So what happened? Anushka Roy, hi, you came late today. So the reaction always favors in the backward direction. आगे बढ़ने का बहुत मुश्किल होगा. When you talk about these two, the reaction is going to take both forward and the backward direction. And if it is greater than 10 cube, reaction is going to favor always in the forward direction. ठीक है? Always in the forward direction. Understand? So when the reaction proceeds always in the forward direction, the reaction fastest to complete. Anushka, your answer is right. Anushka, you did well in the Saturday's class, and same expected in today's class as well. Okay, now answer is C. Your answer is correct. और थोड़ा आगे बढ़ना. At 298 Kelvin, equilibrium constant K1 and K2 for the following reaction. इसका K1 होगा. Sulfur dioxide plus of O2 gives us sulfur trioxide, and sulfur trioxide dissociate to gives us sulfur dioxide plus O2. इसका K1 है, K2 है. The relation between the K1 and K2. So K1 and K2 are reverse, but multiplied with 2. Are you getting or not? But multiplied with 2. Based on that, you can say here it is going to be C. When you multiply with 2 now, it is going to be square. You can say K1 is equal to SO3 SO upon SO2 O2 to the power half. And K2 is going to be SO2 square dot O2 upon SO3. And K1 and K2 is equal to 1 by K1 square. So proper explanation and solutions, everything is given. Yes, power 1 by 2. So it is going to be squared as well. Wonderful. Hemant, nice. Any doubt? Fine. In the following reaction, PCl5 gives rise PCl3 plus Cl2 at constant temperature. The rate of backward reaction is increased by backward reaction का मतलब reaction इस तरफ जाना. Okay, inert gas is mixed at constant volume. अरे at constant volume inert gas का कुछ फायदा नहीं होता. Cl2 is mixed at constant volume. Inert gas is mixed at constant pressure. PCl5 mixed at constant volume. So you see, these are all the traps. Looks like this is a theory oriented question. Yes, it is a logic oriented question. You see, since last 5 years, so NEET examination is all about simple understanding level. Who is going to give the correct answer for this question? Bacha, you want to say D? So I want to say B. Cl2 gas is mixed at constant volume. How do you say D? PCl5, array, PCl5 is mixed. Reaction is backward. Anushka, Saturday's class you did not do any mistake. Today something has happened. Something has happened. So option clicking is also, marking the option is also very costly. Very costly. If you don't know the answer, I am talking about, don't take it as a negative, Anushka. During live examination, when you don't know the answer, there is a meaning that you can regret it. अच्छे तरफ पढ़ाई करने तो अच्छा होगा. लेकिन अरे you know it, solve it and clicked the wrong option or marked the wrong option. अरे you can't deceive yourself. So take it as a positive note, and my dear students, do meditation so that mental gravity will be maintained. Understand? So no problem. से आपके लिए कुछ भला करने के बोल रहा हूँ. So I am not saying, I am not criticizing Anushka Roy. I am not criticizing anything, right? So for that, good remedy is do meditation, right? So that thought process, everything will be normalized. Agree with me? Agree with me, Anushka? Yes. Okay. Now, for the equilibrium process, x plus y gives rise xy. If the concentration of x and y is doubled, the equilibrium constant, equilibrium constant के क्या हो सकता? It's a super awesome question. It's a super awesome question. Heman, you kept quiet. You want to say C? Okay. हेमंत, आपका आंसर क्या होगा? अनचेंज्ड. परफेक्ट. जब तक टेम्परेचर कांस्टेंट है तब तक केसी भी कांस्टेंट हो सकता. एज लॉन्ग एज टेम्परेचर इज कांस्टेंट and rate constant, this equilibrium constant is also a constant. Only temperature can change its value. Okay, now my answer is going to be unchanged. It's a super awesome point. Everybody please make note on it. As long as temperature is constant, equilibrium constant is same. Rushikesh. Hi Rushikesh. Next, 2 moles of PCl5 are heated in a closed vessel, 2 liter capacity. At equilibrium, 40% of PCl5 was dissociated into PCl3 and Cl2. So the value of equilibrium constant is a typical question. NEET examination में typical question, perfect typical question. जल्दी करके बताओ. You just open pen and paper and solve along with me. बच्चों बाटे आप करना है. PCl5 is heated, 40% means 2 moles are taken ना 2 minus 0.4. ओके, ये 2 liter vessel में लिए थे. ओके, so PCl5 gives us PCl3 plus Cl2. So PCl3 is going to be 0.4, Cl2 is going to be 0.4, and these are the number of moles divided by each with divide by 2, because 2 liter vessel का है ना, 2 liter capacity का है ना. And Anushka, you want to say 0.267, परफेक्ट इट इज गोइंग टू बी 0.267. कैसे मैं बता दूंगा आपको. Here PCl5 gives us PCl3 plus Cl2 and 2 moles लिया था शुरू में 0 0. Okay, so T at 0 and T at equilibrium and you're going to get 40% dissociated, 60% बचा है ना. So PCl5 60%. Okay, 2 into 60%. So it is going to be 0.2. It is going to be 0.8, 0.8. So on substituting here 2 liter vessel में you are going to get 0.266 is the answer. Got it? Clear? ऋषिकेश आप भी आंसर देना है. अगले क्वेश्चन सिर्फ आपके लिए. हेमंत, ऋषिकेश, अनुष्का. Next question. The reaction A plus B in the gaseous state to gives rise to C in the gaseous state. It occurs by mixing 3 moles of A, 1 mole of B in 1 liter container. If alpha of the B is 1 by 3 का है, then Kc for this reaction. Now slowly we are entering into the numericals. आप करके बताओ जल्दी. So this question you take less than a minute time to complete this, expecting an answer from Hemant and Anushka, Rishikesh and other students who are there in the online today. Jaldi batao. Okay, well, you want me to solve it? Anushka, come on. The answer for this question is going to be, you want some time, 30 seconds. और थोड़ा देना. हाँ, अनुष्का want to say it's a B, 0.25. Okay, so it take a minute or 30 seconds more. Okay, let's see here. It is going to be B. Anushka, really well. Okay, Hemant, Rishikesh, come on. How to solve this question? A plus B gives rise to C. Okay, when T is 0, 3 mole are taken and 1 mole is taken. 3 mole 1 mole is taken, ये 0 होगा. So C का 1 by 3 होगा. Okay, so it is of B is 1 by 3. So at T at equilibrium 3 minus 1 by 2, 1 minus 1 by 3 and 2 by 3 होगा. B is 1 by 3 का है. So 1 by 3 is subtracted. Alpha is given, right? So that 3 minus 1 by 2, 1 minus 1 by 3 and 2 by 3. You directly put in the Kc expression. So 2c square upon A dot B. So it is going to be 0.25. So it is 0.25 Hemant, but not it is 0.5. Okay, answer is 0.25. You just correct yourself, Hemant. Correct yourself. I want to know where you gone wrong. Where you gone wrong, I want to know. Fine. Next. आगे बढ़ो. Next question. So NEET 2025 All India Test Series Pack. It is all about preparing a NEET examination test series. Whenever you are preparing for an examination, you have to check where you stand, how you are doing. For that, a scientifically designed proper assessment platform which contain all these facilities, and this cost is 5,999, and on the special discount is coming to 2,999 when you apply YouTube 50 off code. Okay, you just description box link is available. Okay, substitution wrong हो गया, कोई problem नहीं बेटा. Practice अच्छा तरफ करने तो अच्छा होगा. And you all just check the description box and click the link and follow the guidelines and try to work on test series pack, and you will be having a seamless NEET examination preparation. All the best. And अगले question, reaction of 2 BaO2 which is actually solid gives rise BaO, which is a solid, oxygen is a gas. Enthalpy of reaction is positive. का मतलब क्या is a endothermic process. It is an endothermic process. Understand? So, at equilibrium, pressure of O2 depends on. ये जो एंडोथर्मिक प्रोसेस है ना, अगर टेम्परेचर बढ़ते रिएक्शन आगे बढ़ते, राइट, सो दैट ऑक्सीजन गैस भी इंक्रीज होगा, सो प्रेशर ऑफ ऑक्सीजन आल्सो इंक्रीजेस. दैट हाई टेम्परेचर increase in temperature. You understand? Here answer is going to be C. Answer is going to be C. Anushka Roy, good. Hemant, good. This time you don't have to do anything wrong. Okay? Right. And tomorrow also we'll be having a session based on ionic equilibrium, some questions from the chemical equilibrium, and start the concept of ionic equilibrium, and you can do it, right? Really, it is going to be a super awesome session tomorrow. I can guarantee you that. Next, C solid plus CO2 gives rise to CO, which are in the gas. You write the same thing in your diary today, Hemant. You copy the text you typed in the chat box and you write it in your diary. Today is 17th February, and by 20th of March, 1st of April, you will be very good at physical chemistry. I can guarantee you that. I promise you for you. Okay, छोटा सा ट्रिक्स भी दे रहे हैं ना मैं, right beta? Okay, so according to this above equation, the partial pressure of CO2 and CO are 4 and 8 respectively. Then find of Kp. You can find out Kp, Anushka, come on. Deal. Perfect. That's the spirit. You want to say C? Okay, Anushka, it is C. You are rocking. And simply Kp expression लिखो. इसका Kp expression क्या होगा? Partial pressure of CO square, partial pressure of CO2, बस उसमें partial pressures दिया. You just simply Kp is equal to 8 square upon 4. You understand? So it is going to be 64 upon 4 is going to be 16. So big mathematical approach. Got it? Clear? For the reaction A plus B reversibly gives rise C plus D, Kc is equal to 9. If A and B are taken in equal amounts, then the amount of C at equilibrium will be. Super question. सुपर क्वेश्चन, नीट एग्जामिनेशन ऐसे क्वेश्चंस आप पकड़ सकते हैं. सुपर ऑसम क्वेश्चन. यू वांट मी टू टेक? आई विल टेक. It's all about. अरे आर यू वेटिंग फॉर द लॉन्ग माराथन सेशंस फॉर ऑर्गेनिक का एक सेशन लेना चाहता हूँ, फिजिकल का एक सेशन लेना चाहता हूँ, सभी को लेना चाहता हूँ, राइट बेटा? आफ्टर दिस 45 days when you are in real time of your NEET examination, I am going to present that. You want to say C? Okay, when Anushka say na, we have to check the answer, it is a C. आप कैसे कर सकते देखो. इनिशियली A plus B gives rise C plus D. Initially 1 mole each are taken. Okay, and 1 minus X and X and X at equilibrium. Now you are at amount of C, I mean to say X सॉल्व करने के कोशिश करो. कैसे सॉल्व करता है? Kc दिया ना, Kc is equal C and D upon A and B, है ना? It is equal to 9. X dot x 1 minus x square is equal to 9. Solve x, quadratic equation बनाओ or algebra. Okay, so x is going to be either 3 by 2 or 3 by 4 आ सकते हैं ये equation का हिसाब से. So that 3 by 4 matches here is a 0.75. My answer is going to be C. Sir, do marathon series for physical chemistry. Also, I am going to do it. A marathon session on physical chemistry. Get ready. Deal is deal, na? But you should be regular. If you complete this 45 days course with me and boost your confidence, तब marathon session आपको फायदा हो जाएगा. Anushka, ready? Right, Hemant. ऋषिकेश कहाँ गया? Monica? Next. At equilibrium, 500 ml vessel contain 1.5 molar each A, B, C, D. If 0.5 molar of C and D are expelled out, what would be the equilibrium constant? What would be the equilibrium constant? Okay, let me say, because time is very less, I just want to give, it is going to be what, how it is a equilibrium constant. Simply you can take 1.5 at equilibrium. At equilibrium, molarity is given. So equilibrium concentrations are given. So Kc is equal to A, B, C, D. Array half reaction is given. A plus B gives rise C plus D. Right? If you take Kc is equal to C and D and A and B. So everything is taken as 1.5. If you remove or don't remove, doesn't matter. Okay, as long as temperature is constant, it is constant. So 1.5 into 1.5 is equal to Kc is equal to 1. If you remove and add, equilibrium positions are going to be changed. But it is same. Understand? Equilibrium constant depends on equilibrium concentrations. That's very important. Clear? This is a sum. What would be the Kc? Okay, that string is missing. Next, for the following equilibrium, N2 plus 3H2 gives rise to NH3. It is for K1. N2 plus O2 gives rise NO, it is K2. H2 plus half O2 gives rise H2, it is K3. The equilibrium constant for this is going to be in terms of K1, K2, K3. So this is a very important model of the question. You have to flip the reactions and you can solve it. Flip the reactions, you can solve it. My answer is going to be K2, K3 cube upon K1. How it is going to be, you can see. So for the equilibrium A, B and C. So A is given, B is given, C is given, and for the reaction this is asked. To make this Kc can be given, we must do K3 cube, so that from equation 1, 2 and 5. So this is 5 and this is 1 and 2, and you have to manipulate this as a K is equal to K2 into K3 cube upon K1. That's fine. That's fine. Now one more question. The reaction A plus B gives rise C plus D is studied in a liter vessel at 250 degrees centigrade. Sorry, it is 25 degrees centigrade. Okay, it is at 25 degrees centigrade. The initial concentration of A was 3N and B was N. What equilibrium was attained? When equilibrium attained, the concentration of C was found to be equal to the concentration of B. So concentration of B is equal to C is equal to N. And what is the concentration of D at equilibrium? Take a minute and do it. Hemant, come on, take a minute and do it. Anushka, what is the answer for this question? Now, when you see here, answer is going to be n by 2. Kaise? When you say a plus b gives rise to c plus d, 3n, n, 0, 0, 3n minus x and n minus x and x and x. So, n minus x you have to calculate it. So, n minus x and x is equal to n by 2. And that is equilibrium concentration at d of d is equal to n by 2. So, it is going to be n by 2. Got it? Supriti Mandal, hello, very good. So, the value of Kp for the reaction is 0.03. What is that equation? H2O plus Cl2O gives rise to HCl plus O2. So, when the partial pressure is expressed in terms of mole atmosphere, then the value of Kc for the same reaction is simple conversion between Kc and Kp. So, Kp is equal to Kc RT to the power delta n. सिर्फ delta n लगा दो, है ना? Clear? Fine. So, you're going to get here going to be Kp is equal to Kc RT to the power delta n. Delta n is equal to मिलेगा आपका plus 1. So, how it is plus 1? It is going to be delta n is equal to 4 plus 1 minus 2 plus 2 is equal to plus 1, right? And put Kc is equal to 0.03 Kp ka hai. This is the Kp value upon 0.0821 R value into it is going to be 700 Kelvin. You have to take into the Kelvin and to the power plus 1. On simplification, you are going to get 5.22 into 10 to the power of minus 4. So, for this question, my answer is going to be A. So, hope you enjoyed today's class, and today we almost discussed the total concept about chemical equilibrium, a short recapture and 30 more questions, and tomorrow we'll resume this class, and 2 more sessions are there for chemical equilibrium and ionic equilibrium, and we are going to revise ionic equilibrium tomorrow, and we'll do some more multiple choice questions. Stay with us. Hope you love this session. Please like and share and subscribe to Infinity Learn YouTube channel. Thank you very much. Signing off, Suresh, Faculty of Chemistry. God bless you all. Bye-bye.